Hi everyone, I'm John Boprosky and welcome to my webinar on how to simulate SerDes systems using a free channel simulator. Please type into chat as I proceed with this webinar, and I'll have a questions and answer session at the end of the webinar. You can also email me with your comments and questions at johnb@serdesdesign.com. Why is this webinar needed? Well, high-speed digital integrated circuits and serializer-deserializer systems have their physical layer modeled and simulated in a channel simulator. Many commercial channel simulators cost tens of thousands of dollars to lease or to own. Today, the SerDes channel simulation technology has matured so that it is available for free using cloud-based tools at SerDesDesign.com. These tools provide the signal integrity engineer a free path for modeling and simulating SerDes systems with existing IBIS-AMI models and with custom behavioral transmitter and receiver models. This webinar is to let you know about this free path. So what is SerDesDesign.com? I created and delivered IBIS-AMI models to 40 plus high-speed digital integrated circuit companies over the past 10 plus years. Over that time, I learned many processes that practically guarantee a better, more efficient, and automatic IBIS-AMI model building process using free tools. I learned how to create high-quality, low-cost IBIS-AMI models while avoiding the standard approach using high-cost tools. Along the way, I learned how expensive tools kill all chances you have of achieving low-cost, high-quality IBIS-AMI models. I created my own tools based on other free tools, Microsoft Visual Studio, CMake, web browsers, HTML, JavaScript, PHP, C++, and more. So why create an IBIS-AMI model is the last thing you should concern yourself with when it comes to being proficient in creating IBIS-AMI models. My tools rely on automation to generate JavaScript code, PHP code, and C++ code to achieve extensible tools with high quality, including automatic IBIS-AMI model generation from behavioral models. I also learned how to escape the costly commercial tool trap that keeps most persons stuck in a permanent high-cost model creation situation. My tools are available for free on the web at SerDesDesign.com with an option to download and install on your local Windows PC with a time-based node-locked license. I'm here to share my learnings over the past 10 plus years to provide you the same channel simulator I've used to create, simulate, and deliver high-quality, low-cost IBIS-AMI models. So this webinar gives an overview of modeling SerDes systems in a channel simulator. Then I introduce the free tools available at SerDesDesign.com. I give a real-world example of simulating a SerDes system with NRZ signaling with the transmitter and receiver IBIS-AMI models, and a PAM4 example using behavioral models. Finally, I'll show you how to get a copy of my SerDesDesign.com channel simulator for your personal use on your Windows PC. So, modeling a SerDes system in a channel simulator. SerDes systems are represented in channel simulators with SerDes channels and IBIS-AMI models per the IBIS Open standard, currently at revision 7.2. This figure shows a typical SerDes system block diagram to be simulated using a channel simulator. This block diagram is generic for any channel simulator, but each tool has its specific way to represent the block diagram. The constituent parts of this SerDes system include the following: the transmit IBIS-AMI model. This model typically contains a transmit equalizer in the form of a feed-forward equalizer with differential IBIS buffer output to the channel. The IBIS buffer can optionally be a 4-port S parameter file. There's a transmit package typically, certainly a channel, and a receive package. These pieces represent the differential channel. Each part is optional and may be represented using S parameter files. There's the receive IBIS-AMI model that typically contains a receive continuous time linear equalizer, clock and data recovery unit, and decision feedback equalizer with differential IBIS buffer input from the channel. The IBIS buffer can optionally be a 4-port S parameter file. So, a key channel simulator property to keep in mind is that it considers that the entire analog content, the green area in this figure, the total channel between the transmit AMI portion and the receive AMI portion is linear and time invariant. As an LTI system, the entire differential analog section in the SerDes system is accurately represented by its single-ended impulse response. The key concept enables the channel simulator to achieve its fast simulation speeds. So the free SerDesDesign.com channel simulator is on the web. There are many popular channel simulators in the market. They provide SerDes signal integrity engineers a valuable tool for evaluating their SerDes system design to understand how their system performs under different conditions. Oftentimes, an SI engineer might not have access to their company simulator tool due to unavailable licenses or the need to timeshare access to their tool with others in his company. When a signal integrity engineer needs to evaluate their transmit or receive IBIS-AMI models under various test conditions with a given total channel, there is a free option available. Use the cloud-based tool that I have on the web at this website. And the SerDesDesign.com channel simulator also supports repeater systems and including an optical repeater system. Free user registration on the website is required to use the tools. So, SerDesDesign.com has many features. Certainly it includes NRZ and PAM4 signaling. It includes many parameterized behavioral models for FFEs, CTLEs, CDRs, DFEs, and more. It includes generation of IBIS-AMI models from the transmit and receive behavioral models. It supports the transmit and receive LTI and NLTV IBIS-AMI models. It includes transmit and receive deterministic and Gaussian jitter, IBIS corner cases, AMI corner cases, use of S parameters to represent the transmit IBIS buffer, transmit package, channel, receive package, receive IBIS buffer. It includes the channel simulation statistical mode and bit-by-bit mode. The display of resultant eye density plots, BER plots, timing and amplitude bathtub BER plots, BER extrapolation, BER contours, the timing and amplitude PDF plots, and various eye statistics, as well as an option to download the same channel simulator onto one's Windows PC using a time-based node-locked license. The SerDesDesign.com channel simulator has been used to model SerDes systems and create custom IBIS-AMI models for 40-plus high-speed SerDes semiconductor companies. Not all the features listed above are included in this webinar. Here's an example SerDes NRZ system using transmit and receive IBIS-AMI models. The system discussed here is based on IBIS-AMI models developed for NXP Semiconductor Incorporated and Silicon Creations LLC. With thanks to John Burnett of NXP and Blake Gray of Silicon Creations for their permission to reference the IBIS-AMI models created for them. IBIS-AMI models are created using the model generation features in the SerDesDesign.com tools based on the behavioral modeling data provided by the companies. And see this document listed here for a step-by-step process for setting up a SerDesDesign.com channel simulation. These models are usable with bit rates from 1 gigabits per second to 28 gigabits per second. Here are some quotes from John Burnett at NXP. All models had no issues or major or minor questions. The IBIS-AMI models delivered by John have worked well from first delivery in all EDA tools and for all bitrate ranges. They were generated in a timely manner and efficient manner. New features were easily added to the models. John was very successful working with legacy design that had limited documentation. And with Blake Gray at Silicon Creations. The feature-rich models were critical to our first pass success. They easily supported customer integration of our SerDes IP. They fixed causality issues found in other channel simulations. So here, the NXP transmit SerDes IP has this block diagram. It represents a 3-tap feed-forward equalizer, and the circuit includes a signal path, a control path with multiple filters, tap gains, on-die impedance structures facing the channel, and inherent in the design is a distributed nonlinearity. The circuit has 3 corner cases. The SerDesDesign.com transmit black box behavioral model was used to generate the IBIS-AMI model. To create the behavioral model for this transmit circuit with 3 corner cases, the transmit circuit was treated as a black box with stimulus response waveforms captured from which the circuit model can be extracted. The transmit output IBIS buffer included the chip on-die impedance and was defined using S parameters for each corner case. The FFE was defined with a swing level with 14 states, a precursor with 25 states, a postcursor with 33 states, and for each corner case. The IBIS-AMI modeling approach was based on collecting SPICE circuit simulation stimulus response waveforms for a defined set of the FFE states. The response waveforms were at the IBIS buffer output. The IBIS buffer characteristic had to be de-embedded from the FFE response waveforms to obtain the FFE-AMI model characteristics. Thus, the combined IBIS buffer model and AMI model provided the same characteristics as defined by the transmitter stimulus response waveform data. The AMI model converts the waveforms to a set of FFE tap gains, tap delays, and tap filtering for the specific bit rate and sample rate used in the simulation. The SerDesDesign.com channel simulator automatically de-embedded the transmit IBIS buffer characteristics from the transmit black box data to derive the AMI characteristics. And here's an example set of waveforms collected for the typical corner case with the postcode set to 11 and the precode swept from 0 to 12. The stimulus waveforms were at a defined bit rate with NRZ signaling and a repeating pattern of 10 zeros and 10 ones. The collected waveforms included the IBIS characteristics, which was de-embedded by the tool to obtain the AMI characteristics. For Silicon Creations, the received SerDes IP had this block diagram. It represents a continuous time linear equalizer, nonlinearity, clock and data recovery circuit, and decision feedback equalizer with 3 corner cases. The received IBIS buffer included the chip on-die impedance was defined using S parameters for each corner case. A behavioral model for this circuit was creating with the 3 corner cases. The SerDesDesign.com behavioral models for front end, for nonlinearity, for CDR and DFE were used to generate the IBIS-AMI models. The CTLE in the receive circuit was inclusive of the receive input IBIS buffer and was treated as a black box with stimulus response waveforms. The receive input IBIS buffer included the impedance and was defined using S parameters, and CTLE is LTI and has 32 states for each corner case. The IBIS-AMI modeling approach was based on collecting SPICE circuit simulation stimulus response waveforms for all CTLE states. The stimulus waveforms were at the IBIS buffer input, and that characteristic had to be de-embedded from the CTLE response waveforms to obtain the CTLE AMI model characteristics. Thus, the combined IBIS buffer and AMI model provided the same characteristics as defined by the receiver stimulus response waveform data. The SerDesDesign.com channel simulator automatically did that de-embedding. The CDR in the receive circuit was modeled using the observed time jitter transfer function corner frequency to estimate for the circuit CDR, and the DFE in the receive circuit was modeled using 5 taps, with each tap defined with a set of states quantized with a set of tap codes. And so here are the example SerDes system results as defined in the channel simulator SerDes system block diagram. The total channel includes the transmit IBIS model, the transmit package, channel, receive package, and receive IBIS model. For the current SerDes system, each of these total channel blocks were represented with S parameters using NRZ data, then 25 gigabits per second, 32 samples per bit with 100,000 analysis bits. The SerDes system was set up in the SerDesDesign.com channel simulator, and here are some test cases. The total channel had this frequency domain response, which shows 25 dB lost at Nyquist, and the red curve was the SDD21 response of the total channel going up to 40 gigahertz, and the channel corrected blue curve is the SDD21 response for the total channel impulse response, which had a sample rate of 800 gigahertz, thus the maximum frequency was 400 gigahertz. Observe that the impulse response accurately tracks the raw S parameter data and has no high frequency aliasing. Here's a plot of the high density for the transmit IBIS-AMI and the total channel. And then we have the reddish colors are the higher density and the bluish colors are for lower density. And this shows that the transmit FEV is able to open the total channel output I somewhat. Then we have the total channel and just the receive IBIS-AMI, and with this high density plot, and it shows that the receive IBIS-AMI model by itself does a pretty good job at opening the total channel I. And here we have the combined transmitter, total channel, and receiver, and the high density diagram on the left, and it opens the eye very well. On the right, there's the transmitter and total channel and receiver timing bathtub BER plot. The raw Monte Carlo BER curve is in red, and it goes down to in this case, the 10 to the minus 5, and the extrapolated BER goes down to 10 to the minus 16, and displaying both of them together shows that the extrapolated BER overlaps the raw data very well with a reasonable extrapolation. So many simulations were run to evaluate the transmit, receive, and IBIS-AMI models over the various states and channels. After many successful simulations, the SerDes models and systems were verified to meet requirements as defined by NXP and by Silicon Creations. So these results are only a sample of the full-featured channel simulation capabilities available at SerDesDesign.com. Here's an example of SerDes PAM4 system, and the example discussed here uses the built-in SerDesDesign.com behavioral models, and you can see this document listed below for a step-by-step process for setting up this PAM4 system. I was using the PAM4 data format with 25 gigabits per second. That's 12.5 PAM4 gigabaud, 64 samples per bit, and 1 million symbols. The transmit behavioral models is listed here, and the receive behavioral models are listed here as well. So here's the results of that simulation with the transmitter and total channel and receiver high density plot. Again, the reddish colors are high density and the bluish colors are for lower density. And on the right, there's the amplitude waterfall BER plot. And the next slide shows the timing waterfall BER plot with a zoom in to see the center half UI area. So the BER curves are shown for the upper, middle, and lower eyes. The raw Monte Carlo based BER curves are shown along with the extrapolated BER curves. The raw data goes down to 10 to the minus 6, and the extrapolated BER goes down to 10 to the minus 16. Displaying both together shows that the extrapolated BER overlaps the raw data very well. Simulations are run to evaluate the SerDes system over many states and channels. After many successful simulations, the SerDes system and its models are verified to meet requirements. During this webinar, I've been discussing the free SerDesDesign.com channel simulator. There are many free features that were not discussed in this webinar. There are many built-in transmit and receive behavioral models that were not discussed. Some were used to create the IBIS-AMI models for NXP and Silicon Creations as discussed in this webinar. Go ahead and try the free SerDesDesign.com channel simulator and let me know what you think. You can also download a copy on your Windows PC. So I'd like to introduce you to your personal Windows PC copy of my SerDesDesign.com channel simulator. It's the same as the free copy on the web. Your personal copy is a premium account and has many benefits. Without the premium account, the user can only use the same cloud-based tool and CPU that all other concurrent users use, which results in slow performance and lack of direct access to any of the user files. Use your data and designs with the privacy of your Windows PC, and this does not require any internet connection. Here's what you get. It's the same as the free channel simulator on the web. It includes instructions and examples. It includes features not available on the web. It provides faster simulations using your local PC. You can access your user area directory and files on your PC. And there's an option to generate IBIS-AMI models from the transmit and receive behavioral models. The premium account has licensing conditions. The channel simulator has a time-based, node-locked license. It's available for 4 months for $600 and for 12 months for $1,500. The price is subject to change. So check it out on my dime. I personally guarantee that you will be successful using my channel simulator. You have a full 30 days to put it to the test. If at any point during that time you don't feel that you get value from your investment, I'll give you your money back. Just contact me at my email here and I'll give you every penny of your investment back. I only want you as a customer if you're 100% happy with your investment. Simple as that. After you purchase the premium account, use it free for 1 month. Your 4 or 12-month license starts after your 1 month free trial. See ordering instructions by using the link below this webinar presentation. Okay? This completes the presentation content of this webinar. I'll end the recording of the webinar and spend time with you to address your comments and questions. Remember, you can also email me with your comments and questions at johnb@serdesdesign.com. Thank you very much.